What's up? What's up? It's your man Jimmy Chan. All right, so we are looking at solving polynomial and rational inequalities. So this is not a whole lot of difference between the two, but there is some difference here, okay? So we gotta be careful. So we're gonna go over a few of these polynomials and then we're gonna do, I think, one of these rational ones. So please pay attention. So when I'm doing so you're welcome to, I'm gonna be kind of going through these steps here as I'm going through it. So you're welcome to always read it, but I'm just gonna go through the steps and then you can always read the steps and kind of make the connections as we go. So the first thing I would do as I'm doing inequalities is that, well, how about if I put it this way? What this is actually saying as a statement, just so you guys know, is that what I have here is that I would need to know what the heck this is talking about. Actually, let me do it this way. What kind of graph this is, right? Well, that graph looks something like this. Okay, so that graph looks something like that. And then this graph here looks something like this. 1, 2, 3, 4, 5, 6. Oops, made this a little too big, too small. Let's do that. All right, so 1, 2, 3, 4, 5, 6. Slope of 1. So what I want to know, so essentially what I need to do is make this go, this is 4, 5, 6, 7, 8, 9, and there. So that's what it would look like, right? So what it's asking about is, hey, when is this curve below or less than this line? So, and that is the case right here, right? Everything from here to here is not going to let me do that. To here, right? So this is x equals -2, x equals 3. Everything from -2 to 3, right? The blue line is below the red line. The blue graph is below the red line. So that's all that is, right? So this is how you're welcome to do it this way if you can catch on these fairly quickly. However, I like to kind of look at it as, hey, let's kind of do everything the same just so that we don't get confused as we see different changes as we're going. So the way I like to do this is saying, you know what? Let's get everything to one side. Let's compare every single equation with the line y equals 0, which is your x-axis, right? This way I know what's below the x-axis, which is negative y values. What's above the y-axis, the x-axis, which is all the y values that are positive. So I know that, I can see that, right? So let's go ahead and do that. So let's go ahead and bring everything to the left side because the x squared is already positive there. So I got to subtract the x, subtract the 6, and that's going to be less than 0, right? So the question is, when is this quadratic less than 0? Well, to do this, let's first find out where the so-called x-intercepts are, right? So let's go ahead and just take this and say, okay, when is x squared minus x minus 6 equal to 0? Okay, this is factorable, so I go, okay, x minus 3, x plus 2 is equal to 0. So at x equals 3 and at x equals -2 is equal to 0, right? So if I was to throw down a graph, oh shoot, not what I wanted to do, no. I guess I'm gonna just have to draw my own graph now. Okay, so let me see here, at -2 and at 3. Okay, so I know that. So now the next thing is, with quadratic is nice because I see that this A right here, oops, that this A right here, doesn't that tell me that A is positive? And if A is positive, what does that mean? That means I'm going to have a stinking smiley face, right? I'm going to have a smiley face. And heck, I can even find my y-intercept if I wanted to, right? Because y-intercept is when x is equal to 0. So when x is equal to 0 here, what is that? When it's 0 here, it's -3. 0 here, so it's going to be at -6. So I can go, okay, 1, 2, 3, 4, 5, 6. So I can actually go, okay, so we can take this all the way down. Bring this in a little bit. Okay, maybe I gotta bring it out a little bit. Man, this is harder than it is. Okay, so I have a graph like this, right? So that's the thing. I have a graph like this. I know it's a smiley face because the A is a positive, right? So now I'm looking at this going, okay, where is this less than 0? Well, it's less than 0. Isn't it less than 0 right here? Right? This is below the x-axis, so that's where it's less than 0, which occurs right here and right here, right? From there to there. So this is x equals -2, and this is x equals 3, right? So anything between -2 and 3 is below. So then my answer is that interval from -2 to 3. Now, why are these parentheses not square brackets? It's because this is a less than symbol, no equals to, right? I don't want it equal to 0. I want it to be less than 0, right? So at -2 is equal to 0. So that's why it's between -2 and 3. Now, I could always write this as -2 is less than x, which is less than 3, right? Which is the same exact way of writing it. They both mean the same thing. They're just in different kind of notation. So they're both the same idea, however. All right, and let's go from there. There you go. All right, so let's take a look at the next example. The next example says solve, let me see, do I have enough space to do that? Okay, yeah, why not? Let's try it. Let's bring this up. I'm going to just bring this over here, all right? So here it is. So what I'm going to try to do is I'm going to go ahead and bring it all to one side. So I have x squared plus x minus 2 is greater than 0. So I did not multiply or divide by negative, so I'm not flipping the inequality. I just subtracted the 2 over to the other side, so I'm okay there, all right? So question is, when is this equal to it? When do I, so essentially I'm finding my x-intercepts, right, or my zeros. I can factor this. This is going to be what, x plus 2 and x minus 1. So I know it's at x equals -2 and x equals 1. Okay, great. Let's see here. So -2 and 1. I can see that this is a positive A. So again, I have a smiley face. And let's see what happens when x is equal to 0. This is 2, this is -1, so it's going to cross at -2. So my graph is going to look something like this. Yay. Okay, okay. Ah, so close. What now? Oh. Now, you guys are thinking, ooh, between right here. Look at what the inequality is asking for, right? The inequality say, when is this graph greater than 0? That means above. Greater than. So it's really talking about this area here, right? This is the two arrows here where it is greater than. So this is at x equals -2, and this is at x equals 1, right? I'm talking about those two above, right? So I can even just erase this and just say, I'm just looking for this and this, right? Not below. I'm looking for those two above because this is asking for greater than 0. So if that's the case, then I'm going from -infinity. Actually, let me use a different color here. I'm going from -infinity to -2. And then I'm going from 1 to infinity. And again, these are not square brackets because this is not including the 0. Okay? And I have two arms here. So if I had to write it, it would be, wow. It would be x is less than -2 and x is greater than 1. Right? Because everything to the left of -2 is going to be greater than. Everything to the right of 1 is going to be greater than. Okay? So be careful. It's not always going to be in between. It could be the other way. All right? So be careful. All right. Let's take a look at this one here. Oh, this is so nice. This is already done for you. Look at that. It's so kind. All right, so what do I know here? I know that my x-intercepts are at x equals -4 and x equals 3. I know this is even, but does it help? And this is odd. Let's see if it helps. I have no idea. Let's just throw it out there. Let's see what happens, just for poops and laughs. All right, so I have an x-intercept at -4. I have an x-intercept at 3. Right? This is no longer a quadratic. It's going to be a cubic. All right? And you're like, what? What's a cubic? Right? So, and this is A is A is positive. That means this graph, guys, is going to do something like this and like this. Let's take a look at where the y-intercept is. So y-intercept, x is 0, so 0 in here would be a 4. 0 in here would be a 1. So it would be a 4 times 1 squared. So it would just be a 4. Okay. So at 4. Ooh. Interesting. Oh, I see now. What this is going to do is this, guys, because this is going to be a cubic, right? So the degree is going to be 3 because here is a power 2, here's a power 1, which gives you 3. So that means there's going to be 2 terms. This is even, so that means it's going to bounce off of here. Right? It's going to bounce off of here. Question, where is it bouncing off to? And then I have this, where it's got to cross this here. And somehow get all the way over here. I just don't know how high it's going to go. Right? This one. It's going to bounce off here. Oh boy. That's actually not a bad graph right there. So we're looking at something like this, okay? So here's the thing. So what is this asking for? It's greater than 0. So this happens to be here, okay? So this is just a sketch, so don't look at it too crazy. So here's what I would tell you to do, okay? So after you figure out where your x-intercepts are, the best thing to do, especially when it starts getting into a polynomial where it's no longer just a quadratic, right? Because a quadratic is easy because there's a smiley face, is a frowny face, and you're done. Where when it gets to higher powers, we start to kind of go, okay, we're not really sure. Now, I did set those down, but once you find your x-intercept, I would just jot down going, okay, here's -4. Okay, here is 3. So what I want you to do is go, okay, let me pick a number in these 3 areas, these 3 zones here, right? And plug it in and see what I get. And see if it's greater than 0 or less than 0. So let's say I put in, let's try out now, -5, right? And let's try 0, since 0 is in here, and let's try 5, right? Let's try those numbers, okay? So actually, let me make these numbers purple here. Actually, not purple. Let's go fuchsia, all right? So I'm going to go ahead and plug those numbers in here, where it would be +4 -3 squared, and see what that equals to, right? So let's go ahead and duplicate that and duplicate that again. And so let's try -5, let's try 0, and let's try 5, right? So let's go ahead and try these and see what they give me. So what do those give me? So I got, this is going to be positive, right? Because it's going to be squared, times a -1 is going to be a negative, right? So this is going to be negative. And then when I do this one here, this piece is negative but squared. It's going to be positive times positive. This is going to be a positive. And here, this is going to be positive. Square is going to be positive. This is positive, so that's going to be positive. Great, positive. Right? So if you look at it, this is positive and this is positive. So that means, now, I sketched the graph. I happen to be right on this, but instead of sketching a graph, this might be easier because now if I'm looking at above 0, that means everything from -4 and on to forever is going to be above 0. Does that make sense? So instead of trying to crank out a graph, it's better off to just stick with this. So I would tell you to forget the graph, create a number line where you're utilizing your x-intercepts because that's where it crosses here and it crosses here, right? There's no vertical asymptotes. There's no anything. It's just this where it crosses, right? Now let's take a look at some numbers in those areas and plug it in to see if it's positive or negative, and then from there make it determine. Since this wants to be greater than 0, great. That means it needs to be positive. So my solution here would be that anything that is x is greater than 4, negative 4 would be my answer, right? Or I can say negative 4 to positive infinity will also be my answer, all right? So that is the way I would go ahead and do that. Actually, with that being said, let's do this. Let's bring this over here, right, to show that that is what I did here. All right, so there's my answer here. All right, on to the next example. Oh boy. Okay, let's take a look at this one here. Now, this is a rational one, right? So we've done polynomial ones for the last 3. Now we're starting with rational. Rational ones are going to be a little bit different, okay? Because we're going to have to look at a couple of different things. So first of all, let me go ahead, and since it's already set to one side, it's equal to 0, I'm good, right? So I have x minus 1 over x minus 3 and x plus 3, right? Is equal to 0. I know it says greater than or equal to 0, so I want above already, right? Where all of these, ooh, yeah, yep, I'm good, right? I want above, so I know I have a vertical asymptote at x equals 3 and at x equals negative 3, right? I have x-intercepts at x equals 1. Because I know I take the numerator and set it equal to 0, right? Because y is equal to 0, and the only way that the y value can equal to 0 is if the numerator of a fraction is 0. So there's my x-intercept and that piece. So I'm going to draw a number line. I have negative 3. I have 1. And I have 3. Okay, so let's pick some numbers here. You know, I want to pick as close as I can. Negative 4, 0, 2, and 4. Okay? And I don't really care about the result. I just care if it's positive or negative, right? So let's go ahead and go, okay, I got blank minus 1 divided by blank squared minus 9, right? Actually, let's do it this way. Okay, so now I can just take this, duplicate it. A few times here. So let's try the negative 4. What does that give me? So the top is going to be a negative 5. The bottom is going to be a positive 16 minus 9. So that's going to be a negative. Is that right? Let me see. Let me give it more space. Because I'm wondering if I should do it this way. The top is going to be negative, right? Negative 4 minus 1 is going to be negative. Negative 4 squared is 16. 16 minus 9 is going to be positive. So this is going to be negative. All right, let's try 0. I get negative on top. On the bottom, I get 0 minus 9, which is negative. So that's going to give me a positive. I'm going to put in 2 That's going to give me a positive on top, and the bottom is going to be a 4 minus 9, which is negative, so that's going to give me a negative. And then I said 4. 4 minus 1 is 3. Oh, I'm sorry, positive. And the bottom is going to be 16 minus 9, which is positive, so that's going to be a positive as well. Okay, so this is going to be negative, this is going to be a positive, this is going to be a negative, this is going to be a positive. So, in other words, my graph is probably going to look something like this. Oopsies. No, it's not going to look something like that because the 3 is a vertical asymptote. So this is probably going to go, and it's going to cross 1, so it's probably going to do something like this. Right? And then something like this. And this is probably something like this, right? So it's probably going to look something like that because it's rational, and the negative 3 and positive 3 is going to look that way. So there's your positive and your negative, and I want to be greater than or equal to 0, which is between negative 3 and 1 is going to be greater than 0, and 3 and to forever is going to be greater than 0, okay? So my answer is now going to be from negative 3 to 1 union with, ooh, I can't include 3, can I? I cannot include 3 because 3 is a vertical asymptote, right? So I cannot include 3, but I include 1, right? Because that's where the x-axis is, the x-intercept is. And then from 3, because I can't include 3, to infinity. So that would be my answer right there. So if I had to write it out the other way, it would be what? 3 less than x less than or equal to 1 union with, this is negative 3. Yep. And then I got 3 less than x, union with x is greater than 3. There we go. So either one of these would work. As a solution. So again, broke it down, find my vertical asymptote, find my x-intercept, applied it on the number line, and then tested a point in each individual region to see if it's positive or negative, and saying, okay, what does it want? Okay? Now, that is pretty simple. That's one of the simpler rational inequalities. Now, what happens when we go a little bit more in depth? Like this one here, right? So this one here is a little bit more in depth in terms of what it's giving us. You see that it's greater than or equal to 2. So here's the problem. If I want to just look at above the x-axis or below the x-axis, what I should do is bring everything to one side. So really what I should do is say, okay, I got 2x squared plus 5x plus 6 over x plus 1 squared minus 2 is greater than or equal to 0. Oh, look at what I'm doing now. Someone's adding or subtracting fractions. Right? Said loved by no one. Okay, so what do I need to add or subtract fractions? I need common denominator. So this 2 would be, I would put it over 1. And what it needs is a x plus 1 squared. Right? I know you want to say it, but you're begrudgingly saying it. Yes, it is true. Okay? So I would rewrite this as one big fraction, which is 2x squared plus 5x plus 6 minus 2 times x plus 1 squared. I'll just write it out. Over x plus 1 squared. I'll just put it equal to 0 for now, okay? So I have to do the math here so that I can maybe combine like terms. So let's keep on going here. And I got, oh boy, this sounds like a long, long road. 2x squared plus 5x plus 6. Oh, you know what? I'm not ready for that yet. Negative 2 times. Let me follow that out. That's going to be x squared plus 2x plus 1 over the x plus 1 squared. Now I distribute the negative 2. So much fun. All right, let's try this. Let's keep on going here. 1 page later. So I got 2x squared plus 5x plus 6. And then I got minus 2x squared minus 4x minus 2. And that's going to be over x plus 1 squared is equal to 0. Oh, a surprise at the end of the road. Look at what happens. 2x squared minus 2x squared. Woohoo! 5x minus 4x gives me ax. Woohoo! And then 6 minus 2 gives me 4. Aww, all that work and it came out so nicely. Isn't that nice? Someone was looking out for me right there, okay? So when you think that it's all against you, it really isn't. It's actually something much, much nicer, okay? So now that we have that, what we want to do is go, okay, so, this seems long. How do I want to go about doing this? Let's go ahead and now. Just trying to save some space, right? But at the same time, not giving up the quality. So let me go ahead and duplicate this and bring it up here. In fact, I'm going to rewrite that. Actually, I don't need to. So let me go and bring this over. So vertical asymptote. It's going to be at x equals -1. And it's even. Now, I don't really need to know that for now, actually. And then the x-intercept, or the 0, is going to be at x equals -4. Okay? Great. And that's all I have. So what I want to do is draw my number line. Plot down my -4. Plot down my -1. And let's pick some numbers. -5, -2, 0. Why not? Let's see where it goes, right? All right, so I have +4 over should I just leave it as squared? Yeah. So I said -5. So the bottom is going to be whatever, if it's positive or negative, it's squared. So bottom is positive no matter how I look at it, right? So this is going to be positive on the bottom. Right? No matter what they are, it's going to be positive on the bottom. Right? So on the top, this is going to be negative, so I'm actually going to have a negative here. -2 plus 4 is going to be positive, so it's going to be positive here. And then 0 plus 4 is positive, so it's going to be positive here. Okay, so if I look, it's going to be a negative, positive, and positive. Now, remember how I said it was even at x? That's even, so that means it's gonna, chances are, and this is gonna be a vertical asymptote, right? Actually, something that you guys might want to even think about doing is actually doing this and making this a dotted line just to remind you that that is a vertical asymptote. So what I was trying to say is that because it's a vertical asymptote and it's even, that means it's either going to go like this or like this, right? Because of it being even. So if one side is negative, the other side is going to be negative. Since one side is positive, the other side is going to be positive as well. So that is a dead giveaway about that. All right. So the question is, that I want it to be greater than 0 or less than 0, right? And the answer is that I wanted this to be greater than 0, and greater than or equal to 0 would be here. But I got to remember that I cannot touch -1, right? So everything on this side to a -4 is kosher. Everything on this side and to infinity is kosher. I just cannot touch -1. So that's the part that I got to be very careful with. So when I write my answer, I can go, okay, so I can include -4, right? Because I can equal to 0. I can go all the way to -1, but I cannot touch -1 because of the vertical asymptote. Then I can start on the other side of -1 and go to infinity, and that's all I got. Okay? Does that make sense? Well, I hope that helps. There we go. Yes, it seems like there's a lot of work here, right? As we're going. And the thing of it is that, you know, one of the reminders for you guys is that you guys probably forgot already. Remember when I first showed you this graph, right? The x squared and this graph, and then we're just looking at what's above and what's below. Yes, that was cute and simple, right? And you're like, can I just do that instead? The problem is that you can't do that with rationals. Rationals are a whole different animal. So why not go through the same exact process for both so that you're used to a process, right? So essentially all I'm doing is finding the vertical asymptote, finding my x-intercepts in terms of rational equations, and then plotting them onto a graph. And one of the suggestions is vertical asymptote, dot it so that you know I can't touch that, so that when I write my solution, I have those parentheses ready. Where with quadratic, I'm really just looking at my x-intercepts, right? And then just plotting those onto the graph and then testing points as well, right? So either way, I'm testing points, but just differently. Well, I hope that helps. If there's any questions, please let me know. See ya. Bye.